Hi, my name is Renee Ma, and I'll be introducing our web application. So, our web application Jam extends the official Spotify live listening activity feature beyond the confines of the official Spotify app. With Jam, users can not only view their friends' current songs, but can also interact by reacting to each other's recent songs. Additionally, our app enhances the user experience by offering monthly, not just yearly, statistics on listening activities such as top artists, top songs, and genres, a departure from the annual tradition of Spotify Wrapped. Our dynamic React application integrates with the third-party Spotify API to fetch a real-time data while also simultaneously storing and managing that data in a MongoDB database. In addition, we collaborated by utilizing a GitHub repository to track the progress of our work and facilitate remote collaboration among team members. We also use the MERN stack and Express.js to build a REST API.
I am Kaylin, and for this segment of the video, I'm going to be walking you guys through how our app handles authorization. And so when users first open our app, they are presented with this login with Spotify button that when clicked, will redirect them to Spotify's authorization page. And we tailored this page to set up several scopes. And scopes are basically what enable our app to access specific functionalities, whether this be getting the user's currently playing song or just like any of their user profile data. And so I will quickly just log in. Okay, beautiful. So then Spotify will then redirect the user to this redirect URI, which we defined in our Spotify developers app. And it will also append something called an authorization code. And this is used by the server to get the access token, and also something called a refresh token for when the access token eventually expires. And so once we have this access token, we are free to make requests to the Spotify API to retrieve the user's profile data. And this profile data includes like a bunch of stuff about the user, but most importantly for our app, it includes their Spotify username. And this is how we handled user management in our database and also how we set up our user schema/model. And so we defined the user model to include the user's Spotify username and then also an array of friends, which would just be an array of their friends' Spotify usernames. And so when a user doesn't exist in our database, we can easily create a new entry using the schema/model with the Spotify username as sort of like their ID and then also an empty array of friends. But if they do already exist, then we can just update their information as needed. And we'll talk a little bit more about that in the other pages of our video.
Hi, my name is Eunice and I'll be walking through the homepage. The home screen dynamically displays a grid of cards, each representing a user's current song playing on Spotify that is obtained by a function that makes a call to the Spotify API to see if a song is currently being played. If a song is currently being played and is not already in the current song collection, the song will append to the corresponding song collection in the database. Each user is defined by a Mongo schema or model that consists of a username and an array of friends. Currently, this user has no friends and thus is the only card displayed. As mentioned before, each username corresponds to a song collection model containing an array of the 5 most recent songs the user has played on Spotify. On the front of the card is the current song the user is playing. Upon clicking on the album cover on this card, an overlay consisting of the user's 5 or 6 most recent songs is displayed. Each song model stores the data for title, artist, album, album cover, duration, timestamp, and likes. Using the use effect hook, the application fetches the user's song collection and friends array and stores the data in the respective state variables to be rendered as shown. Once a user follows a friend, that friend is added to the user's friend array. Then to display the cards of the user's friends, a request is made to our database to retrieve the friends array based on your username. Then the function maps through the array, searching the song collection for the songs array of each friend, which is then rendered onto the page. The user can now see each friend's card corresponding to their respective song collection. Notably, their card functions the same way as the user's card. On the bottom right of the card, there is a like button that sends updates from the client to the backend when clicked. Users have the option to like or unlike a song before the page is refreshed. After the page is refreshed, the database retains the state of the button and the like count is updated accordingly.
Hi, my name is Jenson, and I'm going to be talking about the search functionality in our web app. So our search page has 2 main sections, which are the search bar here at the top and the search results at the bottom. So the way this page works is that when it's rendered, there's a use effect hook that fetches all the users from our database and displays them in the search results by username. So you can use the search bar at the top to search for users, and this is an incremental search, and it does this by via a handle change function that searches the users collection in our database with regular expressions. So you can see if I type K, only the users with Ks in their usernames remain, and I can search for any user like this. You can also see on the right that with every user, there's a follow or unfollow button, and this is rendered depending on whether this user's username is in your own friends array. And the reason why you would want to follow another user is to see their song collection on your homepage. And since now I'm only following myself, there's only one song collection on my homepage, but if I were to follow another user, I could see their song collection on my homepage. And you can see if I refresh the page, this has updated our database. And so the other user's song collection persists. And since that person's username is now in my user's friends array, there's an unfollow button rendered next to their user in the search result, which I can use to remove them.
Hi, my name is Max, and I'll be going over the stats page. So first of all, our stats page is formatted into 3 different parts, which is the top 10 tracks of the month, top 10 artists of the month, and top 10 genres. So first, for the top 10 tracks and top 10 artists, Spotify API conveniently has an endpoint for the user's top data. So because of that, our code was relatively simple. First of all, we just use React context to utilize the access token gained from the authentication process. And then Spotify gave us 3 options for the time range we wanted to accumulate data from, which was 4 weeks, 6 months, and several years. So we decided to go with 4 weeks, which is essentially a month. And Spotify returns the data in JSON format, including parameters such as on the right here, you can see this is the data for, if you scroll up, top 10 top artists. So it obviously includes things like URL, artist name, things like that. And because we only wanted the top 10, we decided to just slice it from 0 to 10 and then map each one of them with the respective data that we wanted to display. And also, one cool thing about this is that there's also a link to the 30-second preview player. So if you can see, if I click on Anyway by Noah Khan, it plays the first 30 seconds of the song. So if you're with your friends, you can show, oh, this is what the song sounds like. This is why it's my favorite, things like that. And obviously, clicking on the respective album or the artist also opens up the official Spotify page. And finally, for the top 10 genres, there was no direct endpoint for this. So I just decided to make a function on my own to calculate using the top 10 artists and top 10 tracks and their genres. And then I just created a map separately for them and then accumulated it into one. And then I sorted it from frequency from highest to lowest to get the top 10.